So on the top of the page, it says indices are powers. So the index or power, it means the same thing. And you can see it here in the example. That power up there, that's what we're talking about, a power or an index. It is an instruction that tells us how many times to write and multiply the number. Can't speak, let me try it again. It tells us how many times to write and multiply a number. So if I want 2 to the power of 5, 2 is what I call the base number. Okay, you can see down here, 2 is the base number. And the 5 tells us how many times we want to multiply it together. So I want to multiply it 5 times. So 2 times 2 times 2 times 2 times 2. Okay? That there is what I call expanded form. Okay, I've written it with repeated multiplication. And then the 32, when you actually times them, the 32 is what you would get. So you need to know those words. You need to know what I'm talking about when I say the base number. Okay, the 2 is the base number. The power or the index is the little number at the top. And if I say basic numeral, that means the final answer at the end. All right, it says note. Index form is when the answer is written with a base and a power. So that 2 to the power of 5 is index form. Factor form is when the answer is written out in multiplication form. So when I had the 2 times 2 times 2 times 2. All right, so here is an example of expanded form. I have 2 times by, make sure yours says times. Holly? Make sure they say times. 2 times by 3 to the power of 4. Now this is just 1, 2 out the front. So I have 1, 2 here. Then for the 3, I have 3 as a base, and it's to a power of 4, which means I need 4 of them. 3 times 3 times 3 times 3. And that is expanded form. That's all there is to it. Indexed laws. The first index law we're going to learn about is the law for multiplying. If I am multiplying 2 index expressions that have the same base, so see how both of these have bases of 2? They have to have the same base or this doesn't work, okay? So if they have the same base and I'm multiplying, we simply add the powers, okay? So for example, it looks a bit weird when you have m's and n's in there. It's a bit easier if I put a number in there. So if I have 3 to the power of 4 times by 3 to the power of 7, the base number stays the same, 3, but I add the powers. 4 plus 7 is 11, so it'd be 3 to the power of 11. That is the first index law, and that is what is written here in this box. If the bases are the same, the powers, the m and the n, we just want to add them together, but they will be numbers, okay, those powers. The second index law is to divide. If I am dividing things, again, they have to have the same base, then I'm going to subtract the powers, okay? And that is easily seen here in this box. And I'll give you an example. So if I went 2 to the power of 7, divide by 2 to the power of 4, the base number stays the same, 2, and I just subtract. 7 minus 4 is 3. Okay, so they are the 2 laws that we're learning today, 2 index laws. So here's our examples. Example number 1, state the base and the power of the following. Okay, you don't have to solve anything. You just have to tell me what is the base and what is the power. The base is the big number at the bottom. So for the first one, it's the 2. The power is the little one up the top, which is the 3. Okay, there can obviously be letters in there. We are doing algebra after all. So in the second one, m is the base, and the power, the little number on the top, is the 25. Question 2, writing 5 to the power of 4 in expanded form. That's the one with all the multiplications. So 5 is the base, And the power of 4 means I need to multiply 4 of them together. So 5 times 5 times 5 times 5. There is 4 of them. 5 is the base and there is 4 of them. That's expanded form.
Could you also just write 5 times 4?
No, that's 20, which is very different to that.
Oh, yeah.
Okay, so it has to be the same number multiplied together 4 times. Question 3. So this is using the index laws that we just talked about. In all of these ones in question 3, we're multiplying. So multiplying, as long as they have the same base, we are adding the powers. So A, 5 is the base. But there's 3 numbers that are the powers. We add all of them together. Is everything okay?
Yep.
Can you put those down, please?
Yep.
And write these answers in.
I've already written them.
Okay. So 3 plus 7 is 10, plus 2 more is 12. Okay, keep the base, just add those powers together. Same thing for B. All of those have 6 as the base. I have 6 to the power of 5. The second one doesn't have a power, so remember that that would be a 1. Okay, so I want to go 5 plus 1 plus 3, which is 9. So 6 to the power of 9. Part C, it doesn't matter how many things that you want to multiply together as long as they have the same base. So all of those ones have a base of 3, and I want to add all those powers together. 2 plus 7 is 9, plus 5 more is 14, plus 10 is 24. 3 to the power of 24. In D, the first 2 have a base of 7. Okay, the second one will be 7 to the power of 1. So those ones I can put together. I keep the 7 as the base. 2 plus 1 is 3, so it's 7 to the power of 3. The last term on the end has a different base, so you cannot add those ones together. It has to stay separate like I've done there. So I just write it again on the end. In E onwards, we now have some letters in there for our bases. So in E, M is the base. Adding the powers, 4 plus 5 is 9. In F, X is the base. Add all of those powers together. 2 plus 6 is 8, plus 3 more is 11. In G, K is obviously the base, but for the first time, we now have numbers in front of those bases as well. If that happens, it means you have to multiply those numbers together. Now, I sometimes call those the big numbers. The big numbers out the front, we need to multiply those together, but don't confuse them with the little numbers, the powers. What do we do with the powers?
Add them.
Add them, that's right. So on your calculator, you might not need the calculator. We want 2 times 3 times 5, which is 30. So that's multiplying the big numbers. K is the base, and then we want to add the powers. Remember, it looks confusing because it actually says a multiplication sign there, but you need to add the powers. So 3 plus 5 is 8, plus 4 makes 12. Same thing for H. Multiply the big numbers out the front. So I have an 8 times a 2, which is 16. B is the base, and add the powers. 4 plus 3 is 7, plus another 7 is 14. Yeah, everyone okay with that so far? Good, because question 3, number 2, I don't know why 3 is written there twice, but anyway. The next question, we are now going on to the dividing. Okay, that's the second index law. If we are dividing, then we're going to be subtracting the powers. Now, divides can be written in 2 ways. A fraction means to divide, and obviously this kind of divide sign means to divide. Okay, so both of those are the same kind of question. For A, 5 is the base. And 7 take away 3 means a power of 4. Subtracting the power. Top one minus bottom one. Same thing for B. 6 is the base. 20 take away 5 is 15. Part C. Now we have our letters in there. So B is the base. Subtracting the powers. 7 take away 4 is 3. And D, even though it looks different, it's the same thing. X is the base, and we're subtracting the powers. 9 take away 3 is 6. Okay, on the next page we have some that are a little bit harder because we have the big numbers out the front again. Okay, the big numbers out the front we have to divide normally. 28 divided by 7 is 4. Okay, then K is the base. And the powers we have to subtract. 13 take away 5 is 8. Okay, so divide the big numbers but subtract the powers. So same for F. 36 and 12, the big numbers out the front, we divide them. 36 divided by 12 is 3. X is the base and subtract those powers. 10 take away 5 is 5. Sometimes the numbers don't divide nicely, okay? So for G, 36 divided by 14, that doesn't go evenly. Now, some of you are better at times tables than others. So some of you can probably simplify that by using cancelling. So I can look at those numbers, I can divide both of those numbers by 2. If I divide the top number by 2, I get 18. If I divide the bottom number by 2, I get 7. Some of you are a little less confident doing that, so you can also get your calculator out and you can get your calculator to simplify any numbers for you. Just use a fraction line, use your fraction button, and you put the 36 on the top and 7 on the bottom. You can't do the letter part, but when you press equals, oh, not 7, it was 14. Let me change that number. So I type it in, right? 14 on the bottom. When I press equals, it simplifies it down for you. Okay, so it's, either way is fine. You can do it without the calculator or you can do it with. Then I need to look at the letters. I have 14, a to the power of 14 on the top and a to the power of 9 on the bottom. So keeping the base, you subtract the powers. So 14 take away 9 means 5. Okay, now I've done that, I can cancel. I've cancelled the 9 off the bottom, which means I have 5 left on the top. I need to write down nice and neatly my answer now. So I have 18, a to the power of 5 on the top, and 7 on the bottom. You should never ever go to decimal numbers or mixed numerals when you have algebra involved. Okay, so I don't ever want to see that's 2.4 or whatever it is. You always leave it as an improper fraction. Yeah? All right, let's try H. There's 2 things there. There's a multiplication sign on the top, and then there's obviously the fraction line, which means a divide. It's less confusing to just do one thing at a time. So let's do that. First thing I should do is the multiplication on the top. So multiplying, I multiply the big numbers. 4 times 6 is 24. Now the x's. X is the base. Add the powers, because we're multiplying again. Adding the powers, 5 plus 3 is 8. And there's nothing to multiply on the bottom, so I'm just going to write 14x squared down again. So my first step, I've multiplied. Now for the second step, I need to do the division part, the fraction part. So again, the 2 big numbers that I have there don't divide nicely. 24 divided by 14 doesn't go nicely. So we can either cancel or you can use your calculator to cancel for you. So without the calculator, I know that I can divide by 2. And I get 12 over 7. Okay? Then looking at the x's, I can subtract off those 2. 8 take away 2 is 6. So I have 6 still left on the top. All right? Writing down the leftovers. I have 12x to the power of 6 over 7. Any questions with that? Yep, Joey?
Might be a dumb question.
No dumb questions.
When you know how to subtract and add the powers.
When there is a multiplying means add the powers, which is why I added to get an 8. But a divide sign like that, or a fraction line, that also means divide. That is when you subtract the powers. Yeah? That's all good. That's a good question. Okay, keeping going. 5x to the 10 divided by 25x to the power of 5. Now, 5 divided by 25 does not go. 25 divided by 5 would go, but the way that is written, we're dividing by the bigger number. If you get a question like that where they don't divide nicely, turn it into a fraction, like the other ones. So you rewrite that to be 5x to the power of 10 over 25x to the power of 5. If you don't do that, most likely you're probably going to write down a decimal number because it's not going to divide out nicely. Okay, so write it as a fraction first. Then, like we did in G and H, we want to simplify the big numbers. So 5 on the top and 25 on the bottom, I can divide by 5, giving me 1 and 5 there. Okay, now the fraction line means divide. So when I do my x's, I am subtracting. 10 take away 5 is going to be 5. So I cancel, that's going to be a 5 left there. Yeah. All right, let's write down what's left. All that's left on the top is x to the power of 5. I did have a 1 written there, but we don't need to write a 1 if it's in front of an x, right? On the bottom, I have a 5 and the x is all gone. So it's just 5 on the bottom. So it's x to the power of 5 over 5. Done. J, they're all multiplications there. So I can multiply all the numbers out the front. 2 times 3 times 6. 2 times 3 is 6 times another 6 makes 36. Now there's 2 different bases here in the letters. I have the x's and I have the y's. Do them separately. So I'm going to start with the x's. Looking through each of my terms here, I have 2 x's, so 2, 3, 4, 5, another 3 there, 6. Okay, that one with no power would be 1, wouldn't it? You can write it on there. If there's no power, then they're powers of 1. Okay, so I had 6, x to the power of 6. Then I want to count up the y's. So let's do the same thing. I have 1 here, plus another 4, so 5, 6. So that extra 1 on the end. So I also have y to the power of 6. And that's done. Okay? Question 4. When we're starting to get a lot more things happening in the question. I'm multiplying 2 fractions together. Now, there's a few different approaches you can do here. You can cancel stuff off and then just multiply what is left. I find that is a great approach to do. The problem with doing that, though, is that unless you are very clear as to what has cancelled, you might miss something. It's very easy for people to miss things. So what I find is the safer option is to multiply first and only do one set of cancelling. Okay? So if I multiply first, multiplying the top together, I go 12 times 7. You all know your 12 times tables. Then I do my x's and y's. So I have x, I have 2 here, plus another 4, so I have x to the power of 6. And then I have y to the power of, remember that's a 1 there, 5 plus 1 is 6 again. Then multiply on the bottom, 21 times 3 is 36. Those x and y's don't collect at all because they're both different bases. So x to the power of 3, y to the power of 6. Now that I've multiplied it's much easier to simplify, I think, from here. So looking at the big numbers out the front. Yeah.
Isn't 21 times 3 63?
Oh, yeah, thank you. I just did, what did I do? I said something completely different, didn't I? 21 times 3 is 63. I completely read that wrong, thank you. So now I want to simplify the big numbers at the front. Okay, given that those numbers are on the larger side, you'll probably find this one easier to check on your calculator. You go 84 on the top, 63 on the bottom, and I get 4 over 3. Okay, so it's telling me that's going to cancel to a 4 and that's going to cancel to a 3. Okay, then I want to cancel my letters. So the divide line means I'm subtracting the powers. So I can subtract 3 from here. So 6 take away 3 is 3. What happens if I subtract 6 from 6? 6 take away 6 is 0. Or in other words, those y's cancel completely away. I cancel all 6 on the top with all 6 on the bottom and the y's are completely gone. Does that make sense? Let's write down what is left. I have a 4 and I have x to the power of 3 on the top, and on the bottom I had a 3. All right, part B. Dividing fractions. We did these before. When we divide, we leave, kiss, flip. Remember that? We leave the first fraction. So that's 7a cubed b squared over 2c to the power of 5. Kiss means that our divide becomes a times. And flip means we turn our second fraction upside down. So that's 2 to the power of 3, c to the power of 20 over 49a squared b. Okay, now this is very similar to part A. We now need to multiply. So we're going to multiply the tops together. The big numbers out the front. Actually, they're not so nice, are they? Because that's 2 cubed, it's not just a 2. So let's write down 7 times 2 cubed. So I'm going to be able to simplify that. I'm just going to write them next to each other for now. Then all my letters, I have an a cubed, b squared, and a c to the power of 20. I'm just putting all the letters together there at the end. On the bottom, 2 times 49. I'm going to leave those. That one I could multiply fairly easily, but I'm going to leave them separate because they're actually going to cancel out nicely in a minute. And I have a squared, b, c to the power of 5. Now that they're all together, the cancelling part. The 2, this is 1, 2 on the bottom. Remember, I have 3 of them up here on the top, so I subtract 1 off there. 3 take away 1 is going to be 2 to the power of 2. Also, 7 and 49, both of those divide by 7, giving me a 1 and a 7 there. Now for all the letters. A squared on the bottom, so 2 on the bottom. 3 take away 2 is 1. There'll be 1 left on the top. B to the power of 1 on the bottom, so I take 1 from the top. That'll be B to the power of 1. And for the C's, I can subtract my 5 off. 20 take away 5 is 15. It's a lot of cancelling out, isn't it? You've got to be nice and neat. Then we write down what is left. On the top, 2 squared. I think it's now safe to say we can write that as a 4 now. We're not going to be able to simplify that anymore. 2 squared is 4. I have a to the power of 1, b to the power of 1, and c to the power of 15. You don't need to write the powers of 1, right? On the bottom, the 49 cancelled down, and we just have a 7 left there on the bottom. Everything else has cancelled off. Sometimes you might find if you don't cancel everything the first time, you might look at it and go, oh, there's still B's on the top and the bottom. I can still cancel further. So always be on the lookout to see if there's more things that can cancel off. So that one was on the trickier side because there's a lot to do in that last question. Here comes your practice, multiplying.